Okay, this is my second chemistry video for AAQ Applied Science, and this is about electronic structure, which is basically whereabouts the electrons are. Now, GCSE Science, now what you learned that the electrons are in orbit around the nucleus, whizzing around the nucleus. You learned that they are in shells, and that each shell can only hold a certain number of electrons. So the first shell is like 2, and then the second shell is 8, and the third shell is 8, etc. Okay, and that's GCSE science or chemistry. For example, magnesium has got 12 electrons, and the first shell has got 2 electrons and it's full. And then the second shell has got 8 electrons and that's full. And then the third shell has got 2 electrons and that all adds up to 12. Okay, so that's GCSE. So we're going to take it a bit further now. We're going to make our model a little bit more complicated. So our model of how the electrons are arranged is getting a bit more complicated. So you've got your atom, and then you've got your shells. So your shells, we're going to call them 1, 2, 3, etc. N equals 1, N equals 2, etc. But then each shell is made up of subshells. Or it might be made up of subshells, as we'll see. So the subshells are called S, P, D, and F. They are the subshells, like shells within shells. And then each subshell is made up of orbitals. And an orbital is like, if it's full, then it's 2 electrons. Yes? Kind of, you can imagine them spinning in opposite directions, yeah? These 2 electrons, and that's an orbital. And then within the orbitals, as I said, you've got electrons. So atoms, shells, subshells, orbitals, and electrons. Yeah, the shells, we said N equals 1, N equals 2, N equals 3, etc. Yeah, and as you move further away from the nucleus, the electrons in those shells have got more energy. So, for example, you do this in physics. If an electron jumped from N equals 1 to 2, you would need energy to do that. And if it fell from N equals 2 to N equals 1, then energy would be released as a photon, whatever. So anyway, N equals 1, N equals 2, N equals 3. These are the shells. Then the subshells, we call them S, P, D, and F. I've only done S, P, and D on here. The N equals 1 has just got one subshell, which is an S. Then N equals 2 has got an S and a P, 2 subshells. And then N equals 3 has got S and P and D. And then N equals 4 has got S, P, D, and F. And these are the subshells. So these are my subshells and these are orbitals. So an orbital is like 2 seats on the bus. Yeah, it's room for 2 electrons spinning in opposite directions. N equals 1 has just got 1 orbital, yeah, which is the s orbital. N equals 2 has got the s orbital, and then there are 3 p orbitals, so that's room for another 6 electrons. So N equals 2 can have 8 electrons, yes? And then N equals 3 has got the s orbital and 3 p orbitals and then 5 d orbitals. So the number 3 shell can actually hold 2 plus 6 plus 10 electrons. So orbitals, as I said, it's like seats on the bus. Each orbital can hold 2 electrons. So S, the S subshell, 1 orbital, so 1 pair of electrons. The first shell can only hold 2 electrons, so it only has 1 s orbital. Then you've got your P, which is 3 pairs of electrons. So the second shell, n equals 2, has got an S and a P subshell. So that's 2 plus 6, so that's 8 electrons. And then the D subshell is 5 pairs of electrons. So the third shell can hold 18 electrons, yeah, because it's got an S and it's got 3p and it's got 5d orbitals. I know that this looks like a nightmare the first time you see it, but honestly, you get used to it. It's pretty straightforward. By the end of this video, hopefully you'll have your head around this. Okay, SPD, 1, 3, 5. How many pairs of electrons do you think the F subshell has? And if you're clever like me, you'll probably have guessed that it's 7. Yeah, 1, 3, 5, 7. Now, filling up these electrons in the boxes, yes, where they go, there's a few rules that we need to know. Yeah. First of all, the boxes with less energy get filled in first. So I said the n equals 1 gets filled in before n equals 2, etc. But then S gets filled in before P, and that gets filled in before D, etc. So boxes with less energy get filled in first. And that's called the Aufbau principle. Secondly, when you're putting electrons in the orbitals, if you go on a bus and you've got a choice, if there's like pairs of seats, and there are seats where there's somebody sat on one of the seats, and there's a double free, which seat would you go into? And I'd probably go into the double seat because I'm a little bit shy. Okay, so it's the same with electrons. Electrons won't share an orbital with another electron unless it has no choice. So if you go on the bus and there aren't any double seats free, that's when you will sit next to a stranger. Okay, so as I said, would you sit next to somebody on a bus if there was a free double seat? Probably not. Okay, and it's the same with electrons. An electron won't go into an orbital with another electron if there's an orbital which doesn't have any electrons in it in the same subshell. Look at this, fluorine. Now these diagrams, electrons in boxes, this is how we can show where the electrons are. So fluorine has got 9 electrons. We say its electron configuration is 1s2, 2s2, 2p5. Now what does that mean? If you look at that and look at the diagram. So n equals 1, 1s2, that's full. Yes, 2 electrons in there. 2s2, that's full, 2 electrons in there. And then 2p5, and in 2p, n equals 2, in the p subshell, the 2p subshell, 1, 2, 3, 4, 5. So 1s2, 2s2, 2p5. Yeah, simples. Notice how we represent the electrons with arrows. And in each orbital, one of the arrows goes up and one of the arrows goes down. Remember I said it's kind of to do with spin. So one electron spinning one way, the other electron spinning the other way within the same orbital. They're spinning in opposite directions. Nice and balanced. Now here's another one, phosphorus. Now phosphorus has got 15 electrons. If we look at the diagram first, so 1s2, that's filled up, 1, 2. 2s2, that's filled up. 2p is filled up. 3s is filled up. But 3p, look at the arrows, yes? So this is people not wanting to sit next to each other on the bus, okay? So the 3 electrons in 3p, which brings us up to 15 electrons, they've got an orbital to themselves, yes? Look at the 3p subshell. Notice how the electrons don't share an orbital unless they have to. And so the electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p3. in the exam, you won't have to draw these boxes. I imagine you'll be given the boxes and you'll have to fill them up with arrows. You may be asked to write down the electron configuration. So all this 1s2, 2s2 business, be able to, if you know the number of electrons, be able to write that out. Okay, that's the electron configuration. Now, one tricky little thing. The 4s2 fills up before 3d. Okay, just one little thing which makes it a little bit more complicated. The 4s2 fills up before the 3d. And now why? Because electrons in the 3d subshell actually have more energy than those in 4s. Yes? So the 4s fills up first. Maybe we should draw the diagram a little bit like this. Yes, if I did the height of the boxes representing the energy, then you can see that the 3D actually has a little bit more energy than the 4S, and that's why the 4S fills up before the 3D. Calcium has got 20 electrons. What would its electron configuration be? And look at that. 1s2, no problem. 2s2, no problem. 2p6, no problem. 3s2, 3p6, but then not 3d, 4s2. Yes, because the 4s2s, those two electrons have got less energy there than they would have in 3d. Okay. Now, a magnesium atom has got 12 electrons. What would the electron configuration of a magnesium ion be? Well, a magnesium ion is 2+. So basically it's got 10 electrons. So 10 electrons, it would be the same as, Harry Henry likes beer by cupfuls not overflowing now. It would be the same as neon, wouldn't it? Yeah, because neon has got 10 electrons. Okay. You need to be able to, now I've just been doing like the elements from 1 to 20. You need to be able to do 1 to 36. Yeah. So filling in ticky boxes, arrows in orbitals for 1 to 36, and also electron configurations from 1 to 36. Okay. And to do that, you're going to need your 4S's and you're going to need your 3Ds. And we're actually going to start filling up 4Ps as well. And it's the same rules, just follow the rules. Remember the tricky little thing between 4S and 3D. Here you go, here's a little bit of practice for you to do. Write down the electron configuration for the following atoms and ions. Look up the periodic table to find the atomic number, which is the number of electrons. And the answers are in 3, 2, 1. There you go. Notice I've put krypton, yeah, bottom left krypton, because that's actually 36. So that would be the biggest one you have to do. Notice that the 4s2 fills up before the 3d. Yeah, 4s fills up before 3d. I mentioned in the last video, the periodic table can be split up into blocks. Does this make a little bit more sense now? Yes, the S block, the P block, the D block, the F block. So that's to do with electrons, isn't it? Yeah. And so maybe these electrons have an awful lot to do with the properties of these elements as well. Yeah. How many electrons are in that outer shell is going to have an awful lot to do with the properties of that particular element.